Hi, so today we are going to discuss statistics with basically what I infer from you people. Like, obviously, there's a very little amount of people are there till now, but still, uh, that you have very less understanding of statistics, and as you have a very less understanding of statistics and whatever statistics or mathematics is going behind data analysis or data science, so there's no point of giving a big advance introduction of some projects or tutorial. So what I decided is to give you some briefs of statistics with art. You have probably scroll the whole internet about statistics and still, like, don't clarify your doubts, have doubts how to do analysis using statistics when you have the data or the project. So you have to search for that kind of projects. You cannot do it from your side, or you cannot infer what you can do. So in this tutorial, basically I will give less talk about what is statistics or what is the, like, methods, or what is null hypothesis or p-value. That's probably you already know. So what I'm going to do here is to give you the codes, how to write the codes and how to think, which thing you needs to apply, or which graph or whatever you have to do when you are doing your own project. Okay, so just try to follow with me, and after that try to implement whatever I'm writing in your own data set. So might be any demo data set. Okay, one question before you ask, why R and not Python? Because R is more familiar or friendly towards statistics and mathematics, and Python is more general language as far as I'm concerned. So what I think that, like, if you are watching Breaking Bad and you are a student of chemistry, so you can, like, gain interest more quickly in Breaking Bad than a student of English. uh, so let's start. The first thing we will look here is the qualitative data. Okay, so what is qualitative data? Is nothing but, so basically you have heard in TensorFlow or whatever project you have did in scikit-learn, categorical data, like in sex, male, female, or in color you have red, green, brown. These are all the categorical data. So that means each data is different from another in class wise. You cannot measure them, like, you can, like in case of a numerical analysis, like it's 5 or 3, you cannot you can measure that the Euclidean distance between 5 and 3 is 2. But what's the difference between red and green? If somebody asks you, other than you know the RGB values, you cannot tell. So this is what categorical data is. So in case of categorical data, how we will measure the statistics of this kind of data. So the first thing is that we are gonna load the library. Sorry, I have to pause the background music for a while. I cannot speak. So we are using the mass library, and we will be using the painters data frame in the mass library. So you can see this is the whole thing. To see the first couple of lines, as you know, use head command. So this is what we have in the data set. So if you just in this painter data look at the school column, okay, you run this, you can see the levels. So this is what defines a categorical variable: a, b, c, d, e, f, g and all that. So these are the categories. Okay. So what we can do with a categorical data is that we can do the frequency distribution, like how many people are right now watching me, male or female, that kind of frequency distribution. And we can plot this distribution as a bar chart or pie chart. So when somebody, your boss or your school teacher, asks you to do a descriptive analysis of this, like you have this school painter in painter data frame, what you have to do is that you have to do the frequency analysis first to understand what is there any skewness in the data. Like if 90% of the people watching this are male and 10% are female, so you can see that easily 9 out of 10% on a very random choice will be male. So it's very easy if you build a machine learning classifier next after learning this to predict whether the person is watching. You have given the age, IP address and all that, and your target is to classify whether he or she is a male or female. So if in a very baseline, it will judge that it will have 90% accurate. Like if it predicts 10 out of 10% is male, still it got 9 right. So its accuracy is 90. So this is just not correct when you are doing machine learning or statistical analysis. So for that, this statistical knowledge is very important whenever you are doing any data science project for your school or your company. So again, let's just give this variable a name. We should run the we now have, as you can see, a variable named school, that is a factorized variable. Factor means category. Okay, you can also, in factor, you can also have ordered fashion, like high, then medium, low, this kind of thing, where you can always know that low is always gonna lesser value than high, but still both are categorical, right? But there is a certain kind of pattern in that. Now to see the frequency of this, the command in R, suppose our school dot frequency is table. So if you right now run it, you will find one table, and if you just print it, you have it that A, B, C, D, E, F, G, H. So if you need to print it on a like columnar fashion to see bottom up, what you can see, you can use cbind, which is basically column bind. And there you go. Now after this is what the whole thing from this table part frequency, right? What is frequency is nothing but if you have ever run a SQL query, that count star you used to put in an aggregate column to see whether how many times a person buys something or how many times a phone number comes up. That count star is the frequency, which is here for A it is 10, for B it is 6, for C it is 6, for D it is 10, for E it is 7. So the next thing that we're gonna look is relative frequency. So suppose now you have a data table or data column. So that has a sex column in it. So what you're gonna do, just table it, and you will find one number and you will make a bar chart or pie chart. That's the first descriptive analysis you can do. Okay, the next thing will come, you can also facet it with different variables to see them according to changing values with another variable included in it later on. So relative frequency is nothing but a normalized version of frequency, which is basically frequency divided by the sample size. And what is the sample size? Sample size is the 100 in 90. So if I have to find the relative frequency of this, how can I do that? That's true frequency divided by number of rows in Painter. Okay, so this will become my relative frequency. So if you run and print it, you will have this. So probably if you sum all this, you will get up, the whole sum will get up to 1, right? Now the next thing, and this is the thing that you have to remember and implement in your solutions, because when you are studying some lesson, it is very easy to follow each modules or submodules step by step. But the real thing is that you have to implement these modules and submodules in your work whenever you are writing one script as a data scientist or analyst. So that script is what your important thing is, not whatever you are learning here. So you have to remember the whole process and implement it there. So like this is what A, B, C, D, E, F, G, H have. It's a very exaggerated value. The values are not in proper format. Okay, so what you have to do, you have to make it clean. Okay, so for that, so these little things you have to write. Now if you run this, you can see it is in a very clean format. So if you just need another decimal point, we just change it here. Will run, it will run perfectly fine. So this is what relative frequency is. Now it's the plotting part. So analysis is as good as your visualizations. Okay, because in old saying there's a word that what sentence is there, picture speaks 1,000 words. So if you're good looking, no matter how much you are earning, you are going to get curves, right? So we have school frequency. Let's print it once again. Print it, right? Now your boss don't want to see, like he is 40-45 years age person, so he has nothing to do with the numbers. He has enough, he had enough in his life. So just what you do, you just write another command which is swap plot, and you just pass the data, and you see now your boss is taking interest in your visualization of your report when you are showing your report in this manner and not in this manner, right? The same thing in different format graphics. And later on we will use ggplot. Right now we are using the base package file. So now what you can do, you can define your colors basically. So this thing is atomic vector, right? I hope you know that. Blue, pink, orange, give green, finish it up with black, right? So we have defined our colors. There you go. Now again call the bar plot graphics, and this time school frequency we need to pass, and we will just call the colors. See, now you have a good looking dude right side of your console. Now most of the people's favorite food is pizza, right? So these are old age peoples, we need some young graphics that can give more information, that can add more value to the data. So what we're gonna do, we're gonna plot it as a pie. So if you just notice this one thing in case of a pizza, that pizza comes with a square box, the thing is circular, and you have it as a triangle. That's pretty interesting thing. So again we are gonna have this school frequency, and we're gonna call pi from graphics, and you see there's a pie chart. So what's the difference between pi and this bar chart? Here you have to be very focused to know that this A and D have the same amount, this B and C have the same amount. But if you see like A and D, right now if you see A and D, you can clearly A and D, B and C, these are all in the same amount, right? And you can also color the pie. Thing is same. These are called functions with parameters. So if the person who build the function is given the space for parameters, you just pass the parameters, it will do its job. And as you can see, we have a colorful pie. Now at last, what you need, that you have done all this descriptive statistics can be done with your categorical variable. Okay, and at the last of everything, like conclusion, you need summary. So first, to get any summary based on this categorical variable, you need to create a logic so that the computer can understand that you want to infer the data, or you want to discriminate the data based on the categorical variable, right? So again, you have that school, you want C school, which is basically school equals to C. Okay, so if you run this, it will create a logical index vector. As you see, C school is false, so you can print it on the console. You can see, so some of the places where your school attribute is C, it is giving true. Some of the places where, most of the places it's AB6, C is in 6 places, so you can count 1, 2, 3, 4, 5, 6, everything else is false. So now if we can apply this on our data set, we have this painter data set, right? What's our logical condition? C school, and we have to find value based on this. So here is your C painter. 6 observations, 5 variables. What are the 5 variables? These are the 5 variables, right? So one thing, if you want to clear the console, this, and it will erase everything that is there. Now what to do if I have to find the mean? Simple mean command. We want to find the mean of composition. As you can see, it's 13. Now what to do when this is good for C school, but most of the cases this is very hectic if you want to do for everything like A B C D E F G H, and there are probably millions of classes or thousands of classes. You cannot do it like this, right? So what is the shortcut of doing it in R? It's basically you want to apply the mean based upon this categorical deviation in the whole table. So as you can see, it wants the vector the index and you want school and what function. I want to see mean of all. Okay. As you can see, we have for A it is 10.4, for C it is 13.2, for B it is 12.2, for D it is 9.1, for F it is 7.2, G it is 13.9 and all that. So in case of statistics, that maximum things, the maximum time what you required is again required standard deviation, as you can see, to get the sparseness of the data according to their school or whatever classification. So another thing that requires is range. You can see the range. Basically it's the minimum value and maximum value for every set it is giving you. And another statistical measure that requires is IQ, right? Quartile range. So see, if you see that in this case for A the range is 17 but IQR is 7. So why we need IQR? That's you have to know. This is for outlier detection. So it has a typical rule. If you go to any statistical books, I think I forgot right now, but it has some level of range after which if you plot a box plot, it will tell you what is the range. It's probably median or plus minus 1.5 IQ. So this is what you have to do in a qualitative data. This kind of thing you can do. Now move on with quantitative data that is not has any quality, as you say, but has quantity, like views, likes and all that on social media. Another thing that we are going to use right now for showing you the quantitative data is Faithful. It's also another data set. So if you don't know or you want to know what this data set is about, what you can do, you can see the structure by typing str Faithful, and brief overview that it's a data frame. It has two columns, waiting and eruption, and both are numeric. It has 272 rows, it has two variables or columns, and it has this blah blah blah. Many things you can do that to check that NA faithful, so it will do all the thing. If it finds any null value, it will just return true. Okay. So we want to declare a variable called duration. We have our data set and we need this column. So first thing what we can check is the range. So this is the range. Now if we want to break this range, it's 1.6, so probably a range of 1.5 to 5.5 or 6, maybe 6 in that case, or 1.6 to 5.2 with a range, no 5.2, yeah, 1.6 to 5.2 with an interval of 0.4. We can break it. So let's define the breaks. So SAP is basically a sequence data. You give your upper value, lower value, which is 1.6. You give your higher value, which is 5.2, and you give by which amount you want to implement this, which is 0.4. And now you simply print it. 1.6 to 2.4, 2.3.2, 3.6, 4, 4.4, 4.8, 5.2. So now if you want to cut it according to your this bucket, basically this is bucket, like some values will fall within 1.6 to 2, some value will fall within 3 to 3.2 to 3.6, right? These concepts will help you while you are doing machine learning or big data analysis in higher stacks like TensorFlow or PyTorch or scikit-learn or even R, Spark R. In that case, it's like whenever you want to apply categorical column features in case of TensorFlow, this thing will come, and for outliers they use OV, out of vocabulary. We'll also go in details in later. So just cut. Duration is our data. We put this breaks to apply, and we will just give it duration bracket. So we have a duration bracket, right? Now duration bucket is table duration bucket. And what do you get if you now print it? So see, you started with continuous numerical values and you converted it into some meaningful, right, into some categorical values. So it's probably age Like if you ever do the Titanic in Kaggle, there are one column of age variable. So age in itself, if you plot it in, that's a continuous value, so it will plot as a histogram, and in case of that, that might not be any useful for you. So in whenever you are doing feature engineering, so you can do the bucketized thing. So to bucket the whole age distribution in a systematic manner to see the frequency. So suppose your Titanic has more age, like more people falling in an age bucket of 26 to 34, and you can see that the survival rate in case of Titanic is very high in case of 26 or and 34. So if you remain that as a continuous value of age, that is pretty much tough for the model to infer the pattern. But if you just do a categorized thing, so model can easily see that it has the highest peak, so probably it has the highest number of samples there, so the survival will definitely gonna high, because most of the cases, most of the times, that points are coming from this bin, right? Now what you can do, you can again this time plot the distribution as we have learned. Use this. So as you can see, we have this is the bucketized bar plot, right? So, and if the same data, the data is duration, as you can see, the same thing, but this graph has more meaning than this. As we also gone through histogram, now it's time to check for relative frequency distribution. So what is our duration? Our duration is the eruptions variable. Take it from faithful data frame, right? We also have breaks in our console. We also have duration bucket, right? So relative frequency will be nothing but duration bucket divided by n row, right? So we just run it. This is frequency. And we can, with the help of code, we can also customize this. Next important thing in case of quantitative variable is cumulative frequency. So what is cumulative frequency? It's like you like to collect coins, right? You are a saver in that sense. So each day your dad gives you 2 rupees or 3 rupees or whatever currency is used in your country, and you like to save it. So day 1 you have a 2 rupee coin, day 2 you have a 3 rupee coin, so at day 2 you have a total of 5 rupee coin. Day 3 you have another 1 rupee coin, so at the end of the day 3 you have a total of 6 rupee coin. So this 6 or this 5 is what your cumulative distribution or your cumulative value at the end of this day 2 and day 3. So how can we use cumulative frequency here? We have again duration, we again breaks, and we have frequency. So cumulative value here will be cumulative summation of this duration unit. Okay. So if you right now just plot the value C/9. There you go, you have the cumulative values. So it's ever increasing, right? Because what it's gonna do, that 16 to gain, the first gain has a 51 row count or whatever, that 2 to 2.4 has 89 minus 51, so it's adding up, it's stacking. This is what cumulative distribution. So what you can do with cumulative distribution, how you gonna represent cumulative values, right? So this will gonna help you to see how your sales performance is in your company, or whatever, how many chapters you have finished. So I'm writing the code. Suppose comes in frequency 0 equals to always remember this thing is for discrete values, like it's not continuous, it's numerical or quantitative. Obviously in quantitative you have two things, one is discrete and one is continuous. Discrete means grains, you can say grains, yeah, you can say grains, or number of bikes. And continuous means water, milk, because you cannot count. The thing you can count is this discrete, like number of tops. But in case of continuous variables, the things you cannot count, that's not discrete, like not digitalized. It always has a probability distribution within it, like what it does in case of softmax. Whenever you're gonna use CNN, you will find softmax there. That thing is what is continuous. So to plot this, we have breaks. Just find cumulative frequency. Now we just want to define that main is basically what title you want to give to your graph. Xlab, which is basically labeling the X. Duration in minute, and the same cumulative summation, right? So that's it, the whole thing. And what we want, we also want line. Don't just only want the plot, we want line. Cumulative summation, which is ever increasing. Like see here, the increasement rate is decreasing, but it's still increasing. The values are less, but this point is lower than this point. This point is lower than this. This is lower than this, and this will continues. So this helps you to find trends whenever you are doing time series analysis. You can see whether it's decreasing or increasing, like due to the enhancement or the popularity of renewable energy. The fossil fuel industry getting a massive backlog day by day, so people are now investing on renewable energy. So that how they gonna get sure about this? This is the trend line, which is basically will give you that with over time, if you see this as a time, whether the my graph is increasing or decreasing. Now another important thing, which is basically I find it very similar to histogram, is steam and leaf plot. Okay. How to define the steam your duration? It's a histogram like plot. If you see, if you just pivot this whole thing, like if you change the x to y and y to x, you will have a histogram. If I move my answers, you could see in this case what happens in this 2 3 4 5, and in this this is your 16 20 30, and in this case here is your 16 18 20 25 or whatever, and here is a 2 3 4s 2 3 4s, right? This is complete reverse. Now the most important thing, whenever I think if you ever use Python, most of you always use Python. So what you do, Seaborn pair plot, right? So in pair plot, what you judges or what you see is a similarity. So The major similarity between two variables, the one plot, is scatter plot, which is most oftenly used. So in case of scatter plot, probably this is the last thing that we will do. So we'll cover that qualitative and quantitative measures in next. If you want to listen, we can go with hypothesis, type 2, type 1 error, inference, how to do like machine learning basically, and how not just to copy and paste, because copy pasting won't give you any job, right? If you don't answer the questions in front of your interviewer, or you don't have that much understanding in yourself, so you always be in your doubt whether you are a working person or you're just a student. So let's just duration and weighting be defined with this thing. Now if you just call a plot on duration, faithful, good. Waiting, you will find a relation. Okay. So what you can infer for this scatter plot quickly, if you if you follow me, I have posted many videos upon this, that you can see there's a clear clustering pattern between duration and waiting, right? See, this is one group and this is another group of people. So suppose you have 50 variables, and you have to do 50 variables you have taken for your sales team from of your customer data, and you want to do a clustering, like customer segmentation. Okay, so in that case, if you run PCA or any other latent component decomposition, like that means you are going to reduce the number of variables from 50 to a meaningful count, like 3 or 2 or 4 or whatever, and then if you have from 50 to 2, and if you then plot that two basic variables, like your principal component 1, like your hygiene values, and principal component 2, so you'll get a curve like this. So you can easily segment your customers based upon these two values of principal component, which is in previous next to impossible when you have a 50 number of variables, right? So this is for today. If you find it interesting, if you gain some knowledge, we can continue. Otherwise I will just post to my projects and that's it. So you have to remember that you cannot use this scatter plot or histogram as we have done here in this script, but you have to take an idea from this, and you have to find a way, how can I implement this chart in my data. So if you don't have a variable that looks like you can implement bar plot or pie chart, so you have to make the data in that way, and that's what your feature engineering or your part of intelligence comes when you are doing machine learning with custom machine learning. Basically, if you do auto machine learning, you don't have to do anything, the algorithm will take part of it and take care. So anyways, bye, take care.